Hi, my name is Samir Desai, and in this video I'm going to teach you how to identify whether a compound is oxidized or reduced.
In an earlier video, you learned how to assign oxidation numbers to carbons. Make sure to review that video if you're unfamiliar, because a strong understanding of this concept is essential to this lesson. Oxidation numbers allow organic chemists to track the flow of electrons between an atom of interest. In order to determine if an atom is oxidized or reduced, you'll have to first be able to identify an oxidation reduction or redox reaction. In this video, you'll have to identify which carbon is losing or gaining bonds. Then you'll have to assign oxidation numbers to that same carbon for the reactant and product side. Remember that oxidation number equals the number of expected valence electrons in the atom of interest minus the actual number of electrons. If it truly is a redox reaction with the gain or loss of bonds, the oxidation number will not be the same between the atom on the reactant and product side. The atom on the reactant side has an oxidation number that is either larger or smaller than the oxidation number of the same atom on the product side. A reduction reaction occurs when the oxidation number goes from big to small between the reactant to the product, or when there's a reduction in the oxidation number. A reduction indicates a gain in electrons. In contrast, an oxidation reaction occurs when the oxidation number increases on the atom, going from reactant to product. Recall that oxidation number is a way to track electrons. So if the oxidation number is increasing, it means that the atom is losing electrons. Remember, Leo the lion says GR, where Leo stands for loss of electrons, oxidation, and the GR, which symbolizes the sound a lion makes when roaring, is to remind you that a gain of electrons is reduction. Of course, assigning oxidation numbers and comparing can be a task. This is a quick trick to observe an oxidation or reduction reaction. A gain of bonds to oxygen is an oxidation, while a loss of bonds to oxygen would be a reduction reaction. If you think back to assigning oxidation numbers, recall the importance of electronegativity. The more electronegative oxygen will pull electrons away from the carbon, resulting in carbon losing electrons. Rewording that statement, the actual number of valence electrons in carbon will decrease with each additional bond to an oxygen, resulting in the oxidation number increasing. So oxidation occurs when there is an increase in the number of oxygens bonded to the carbon, and the opposite trend holds true as well. Reduction is a decrease in the number of carbon-oxygen bonds when you compare that same carbon of interest between the reactant and the product. Alternatively, in a carbon-hydrogen bond, the atoms are not split evenly, and this time, both electrons go to the carbon. You'll see an opposite trend compared to oxygen. As the number of bonds to hydrogen increases, then there will be an increase in the actual valence electrons on the carbon, leading to a decrease in the oxidation number. This can all be summarized by saying that reduction is observed with an increase in the bonds to hydrogen, and oxidation is a decrease in the bonds to hydrogen when comparing the atom on the reactant to the product side. Take a look at the molecule drawn below, formaldehyde. It's the simplest aldehyde and great for showcasing the effects of reduction and oxidation. Notice that formaldehyde has a carbon with 2 bonds to hydrogen and effectively 2 bonds to oxygen because it's a double bond, so it's counted twice, which is why it's in the middle. Reducing the aldehyde, meaning we see an increase in hydrogen bonds or a decrease in the bonds to oxygen, will result in methanol. Notice here that there was a decrease in the bonds to oxygen because it went from a double bond to a single bond. Reducing it further would yield a methane. Alternatively, oxidation is the increase in the bonds to oxygen or a decrease in hydrogen bonds. So what does the oxidation of formaldehyde look like? Oxidation of the formaldehyde results in an acid, particularly methanoic acid, and this can be further oxidized into carbon dioxide, and we can see all the bonds to oxygen in this molecule that it's gained. Let's use this knowledge to identify when a compound is being oxidized or reduced. In this question, we're given a compound in A, B, and C, and asked if the product has been oxidized, reduced, or neither. There are multiple approaches to this question. A should look familiar from the previous slide. The reactant is an alcohol, so the carbon is bonded to one oxygen, while the product has a carbon double bonded to an oxygen on either side. The compound has an increase in the number of bonds to oxygen, going from 1 to 4, so this transformation is oxidation. An alternative way to approach this is by assigning oxidation numbers to the carbon, as we learned in an earlier video. Taking a look at the carbons double bonded to each other, notice that these are the only carbons whose bonds change between the reactant and product side. So we know the oxidation numbers will also change. The top carbon has an oxidation number of 0, and after reaction, that same carbon has gained a bond to oxygen, resulting in an oxidation number of +1. Here, we're going from 0 to a +1. The only way to be more positive would be to lose an electron. Recall Leo the lion says grr, so a loss of electrons is oxidation. But we're not done here. There's another carbon on that double bond that also has an oxidation number of 0. And after the reaction, that same carbon has gained a bond to hydrogen, resulting in an oxidation number of -1. This is a gain of electrons, so it's reduction. Since there's an equal amount of oxidation and reduction happening in the same molecule, then there is no net change in oxidation, so neither. Lastly, C. This molecule looks very different when compared between the reactant and product, but let's assign oxidation numbers to the carbons and see if we can label the transformation. Again, the area of interest will be around the carbon-carbon double bond. The carbons on the reactant side are bonded to 3 carbons and 1 hydrogen, so both will have an oxidation number of -1. And after reaction, those same carbons have gained a bond to hydrogen, resulting in an oxidation number of -2. A decrease in the oxidation number for both carbons means that the molecule has been reduced. You should now feel confident with identifying whether a compound is oxidized or reduced. Make sure to follow up with practice questions to test your knowledge.